In this video, I am going to talk about regarding the bisection method. So before talking about the bisection method, we need to understand two facts regarding the bisection method. The first one is that we need to have continuous function in some interval such that a1 and b1. So in this figure, this is our continuous function in between a1 and b1. Here I have taken a is equal to a1 and b is equal to b1. Now the second one is that we need to choose 2 points in the interval such that fa1 and fb1 are opposite sign. It means in this figure for the a1, fa1 have negative sign, for the b1, fb1 have positive sign. Therefore we can say that fa1 and fb1 are opposite sign. Also definitely we can say that this continuous function intersects the x-axis and we have a rule. It is p. So we need to find the value of p by using the bisection method. So let's see how to find the value of p by using bisection method. The first one is that we have to reduce this interval approaching towards p. So we have to get the midpoint between a1 and b1. It is p1. p1 can be get this one. p1 is equal to a1 plus b1 over 2. Otherwise p1 can be right. p1 is equal to a1 plus in the bracket b1 minus a1 over 2. By solving this equation we can get this one. Next we have to check the sign of the fp1. So it is positive sign, and also we have negative sign for the fa1. Therefore we can say that our root is between a1 and p1. This is our new interval. Also it is our second iteration. In here I have taken a1 is equal to a2 and p1 is equal to b2. Also I can get some relationship between second iteration and first iteration. So I can write b2 minus a2 is equal to half of the b1 minus a1. This distance is the half of this whole distance. Now again we have to find the midpoint between a2 and b2. It is p2. Also we have to check the sign of the fp2. It is negative sign and we have positive sign for the fp1. Therefore we can say that our root is between p2 and p1. Our new interval is p2 and p1. Also I have taken p2 is equal to a3 and p1 is equal to b3. This is our third iteration, and I can write b3 minus a3 is equal to half of the b2 minus a2. Next we have to find the midpoint between a3 and b3. It is p3. Also we have to check the sign of the fp3. It is positive sign. Therefore we can say that our root is between p2 and p3 because fp2 have negative sign and fp3 have positive sign. So our new interval also p2 and p3, and I have taken p2 is equal to a4 and p3 is equal to b4. It is our fourth iteration, and I can write b4 minus a4 is equal to half of the b3 minus a3. Now we have to do this process again and again until find the value of p. Therefore I can get for the nth iteration bn minus a1 is equal to half of the previous iteration. Now I am going to get an inequality by using our root of p, midpoints and intervals of each iteration. So our first midpoint was p1. Therefore absolute value of p1 minus p, this distance, less than or equal to b1 minus a1 over 2. It is this distance. Therefore we can write this expression, and we have gotten a is equal to a1 and b is equal to b1. Therefore this expression I can write b minus a over 2 to the power 1. Now our second midpoint was p2 minus p, this distance, less than or equal to b2 minus a2 over 2 is this distance. Also I can write b2 minus a2 by using the b and a. Therefore I can write b minus a over 2 to the power 2. Also our third midpoint was p3. Therefore, P3 minus P, absolute value of P3 minus P is this distance, and we can write it is less than or equal to B3 minus A3 over 2. It is this distance. Also, I can write B3 minus A3 over 2 is equal to B minus A over 2 to the power 3. Therefore, now we have sequence. So, P1, P2, P3, P4. P1 minus P is less than or equal to B minus A over 2 to the power 1. P2 minus P less than or equal to B minus A over 2 to the power 2. Here for the P3 we have 2 to the power 3. For the P4 we have 2 to the power 4. So finally in midpoint we can write absolute value of Pn minus P less than or equal to Bn minus An over 2 is equal to B minus A over 2 to the power n. Finally we have this equation. Actually, this inequality very important to us in the equations to find the number of iteration. So let's see the example regarding the bisection method.